Okay, so get this right. Like, imagine teaching a computer to translate languages,
Mm,
but like not by memorizing phrases, by actually understanding the relationships between words, like we do.
mm.
That's the power of attention in AI, and that's what we're going to be diving into today
Yeah,
with this paper. Attention is all you need.
it's a good one.
Yeah, we've got excerpts from it. It's this landmark Google AI paper. It's kind of technical,
Oh, yeah,
but don't worry, we'll break it down.
we will.
Make it make it digestible,
Absolutely.
By the end, you'll get how this new model, it's called the transformer,
Yeah.
changed the game for machine learning, and why its impact goes way beyond just translation.
It really is fascinating. What's so groundbreaking is that it didn't just like introduce a new model.
Mhm.
It really presented a whole new way of thinking about how machines process language.
Right. So let's start with the problem that this paper was trying to solve.
Yeah.
It talks about the limitations of these older
Yeah.
models for handling language, especially recurrent neural networks
Right.
or RNNs. I have to admit, I always struggle to picture what's actually happening inside these models.
Well, think of RNNs like someone reading a sentence, right?
Okay.
Word by word, trying to remember all the previous words to understand the current one.
Okay.
The problem is this sequential processing. It gets really slow, especially for long sentences.
Makes sense.
It's like trying to understand a novel,
Uh-huh.
one word at a time,
Okay.
holding the entire plot in your head.
Gotcha. So it's not just about speed, though, right? It also mentions something about parallelization.
Exactly.
Yeah.
With RNNs, you can only process one step at a time,
Hmm.
making it really hard to train them efficiently.
Hmm.
Think of it like a grocery store
Oh, yeah.
with a single checkout line.
Yeah.
When you have a cart full of items,
Yeah.
not very efficient.
No, I've definitely been in that line. Okay, so RNNs were a bottleneck. And I know they tried using convolutional neural networks, CNNs,
Right.
famous for image recognition.
Yeah.
Did those work any better?
They offered some improvements in speed,
Yeah.
but CNNs still struggled to grasp those really long-range connections in a sentence.
Okay.
Imagine trying to understand a story,
Mm-hmm.
but by only reading a few paragraphs at a time,
Okay.
you might miss the subtle connections,
Uh-huh.
between characters and events that happen across chapters.
So they were faster, but they still couldn't quite grasp the whole picture.
Yeah.
This is where the transformer comes in, right? And this
Mhm.
this whole idea of self-attention,
Yeah.
it sounds kind of magical, like the model suddenly gains awareness.
Yeah, it's definitely a clever approach. With self-attention, the model can analyze all the words in a sentence simultaneously and figure out how they relate to each other all at once. It's like having a bird's eye view
Mm.
of the whole sentence
Uh-huh.
and seeing how each word connects to every other word.
So I'm starting to see how that could be more efficient than just reading word by word, but how does it actually do that?
Yeah.
The paper mentioned something about uh, queries and keys and values,
Right.
and honestly, it lost me.
I understand. It can be a bit abstract. Think of it like searching for something online.
Okay.
You type in a search query.
Right.
And the search engine compares your query to keys,
Uh-huh.
which are like the titles and descriptions of web pages.
Okay.
The closer the match, the more attention the search engine gives to that page.
So if I search for best coffee shops,
Right.
the search engine would pay more attention to websites with those keywords in the titles.
Exactly. And those websites would have values,
Okay.
which is the actual content, reviews,
Yeah.
information about those coffee shops.
Mm.
The search engine uses the attention that it calculated to rank and display the most relevant results.
So in the transformer, the query is the word the model is currently focusing on,
Uh-huh.
and the keys are all the other words in the sentence. It's comparing them to see how related they are.
Precisely. And the values are the meanings and context associated with each word.
Right.
The model uses the attention weights to blend those values,
Right.
creating a really rich understanding of each word within the whole sentence.
Okay, that's starting to click. So instead of processing words one by one,
Yeah.
the transformer considers all the words and their relationships at the same time.
Right.
That's a big departure from how we were thinking about language processing before.
It is. And what's even more revolutionary is that the transformer relies entirely on these attention mechanisms.
Okay.
It completely ditched RNNs and CNNs,
Mm.
making it a purely attention-based model.
Wow, they went all in on attention. Okay, so we've established that self-attention is like the heart of the transformer.
Yeah.
But why is it so much better than those older approaches? I know the paper had a table comparing the different types of models.
It does. That table highlights three key advantages of self-attention: computational efficiency,
Okay.
the ability to process things in parallel,
Mm-hmm.
and handling long-range dependencies.
Okay, let's break those down. What do they mean by computational efficiency?
It gets a bit technical,
Yeah.
but basically, self-attention can be faster than RNNs when the sentence length is shorter than the way the model represents the words,
Mm.
which is the case for a lot of machine translation tasks.
So for most practical applications, self-attention is a win in terms of speed.
Right.
What about this parallel processing advantage?
Remember that grocery store analogy?
Uh-huh.
Well, self-attention is like having multiple checkout lines open at once.
Okay.
It can process all the words in a sentence simultaneously,
Mm.
which makes it way faster to train these massive language models.
Okay, that makes a lot of sense. Okay, and lastly, what about those long-range dependencies? We talked about how CNN struggled with that.
Right. RNN struggle too. Imagine trying to remember a tiny detail from the beginning of a long, rambling conversation.
Oh, right.
It gets lost in the noise. Self-attention, on the other hand, can directly connect words across a whole sentence, no matter how far apart they are.
Okay.
It's like having a direct link between the first and last chapters of a book,
Mm-hmm.
making it much easier to understand the connections.
So basically, self-attention allows these models to learn much faster,
Yeah.
handle way more complex language,
Yeah.
and actually make connections between words like we do.
Exactly.
That's huge.
It is.
I'm starting to see why this paper was such a game changer. But this new architecture,
Yeah.
like how does all of that actually work in practice?
That's where things get really interesting. The paper describes a pretty unique architecture that's key to the transformer success.
Let's dive into that then.
So welcome back to our deep dive into attention is all you need.
Now, before we jump into the Transformers architecture, you mentioned something about visualizations
Right.
that let us actually see how the model is like thinking.
Yes. These attention visualizations are amazing. They're like a window into the model's thought process, showing us which words it's focusing on when it's processing a sentence.
So it's not just about knowing the model can find these relationships. We can actually see which connections it's making.
Exactly. And the really cool part is that these visualizations often reflect like our own understanding of language.
Yeah.
You know,
Yeah.
we might see the model paying strong attention to a verb and its object, or to a pronoun and the noun that it refers to. It's like watching the model learn grammar and sentence structure,
Yeah,
just like we did in school.
that's pretty wild. It's almost like the model is learning to read in a way that makes sense to us.
That's a key point. These visualizations help us see that the model isn't just like crunching numbers.
Right.
It's representing language in a way that's meaningful, closer to how humans understand it.
It's not just about getting the right answer. It's about getting there in a way that we can understand and trust.
Absolutely. It's like the difference between blindly following a GPS
Okay.
and actually understanding the map yourself. You know,
Right.
these visualizations give us more confidence that the model is actually grasping the language, not
Yeah.
not just finding some statistical trick to solve the task.
Okay. That's fascinating. But it makes you wonder if a machine can learn to understand these relationships like we do.
Yeah.
What does that tell us about the nature of language itself?
That's a profound question. Honestly, one that researchers are still debating. The success of the transformer suggests that maybe the core of language really is about these patterns of attention, these connections between words.
It's almost like the model is rediscovering the rules of language on its own, just by analyzing tons and tons of text.
Right.
Okay, so this idea of self-attention was so powerful that it sparked a whole new wave of AI development, right?
It did.
Models like BERT and GPT-3, which everyone's talking about,
Yeah.
took this concept and ran with it.
That's right. Both BERT and GPT-3 are built on the transformer architecture.
Right.
They take this idea idea of self-attention and scale it up massively, training on huge data sets of text and using even deeper and more complex models.
Wait, so they're like super powered versions of the original Transformer. Can you give us an example of how these models actually work, like in practice?
Sure. BERT, for instance, uses something called masked language modeling. Imagine giving the model a sentence, right?
Yeah.
With some words blanked out and asking it to fill in the blanks.
Okay.
By doing this over and over, BERT learns to deeply understand the context of words and how they relate to each other.
Kind of like a supercharged Mad Libs game for AI.
Exactly. And then you have GPT-3, which is a generative model.
Yeah.
That means it can actually create new text that's often indistinguishable from something a human would write. It can write stories, poems, even computer code, all thanks to this same self-attention mechanism that we've been talking about.
So to recap, this attention is all you need paper really was a pivotal moment.
It was.
It's incredible to see how much has changed in just a few years because of it.
It really is. The Transformer has basically become the architecture for natural language processing, and its influence is expanding into other areas of AI too.
I've even heard about them being used for image recognition, music generation, even discovering new drugs.
It does seem like attention might just be all you need.
Yeah.
But jokes aside, the success of the Transformer has really opened up a world of new possibilities for AI. It's a very exciting time to be working in this field.
Okay, so we've covered a lot of ground here.
We have.
We talked about the limits of those older models, the whole concept of self-attention, and how the Transformer like revolutionized the field.
Right.
We even peeked into the mind of the model with those attention visualizations.
We did, and all of this is built on this pretty unique architecture described in the paper. It's the key to how the Transformer works its magic.
Okay, let's finally break down this architecture then. I'm ready to see what makes the Transformer tick. Okay, so we're back, ready to finally tackle this Transformer architecture. I have to admit, I'm a pretty visual learner, so I'm hoping we can paint a picture here of like what's going on under the hood. You know?
Absolutely.
Yeah.
Visually, the Transformer follows this encoder-decoder structure, kind of like a communication system. The encoder takes the input, right, like a sentence in one language, and breaks it down into these meaningful representations. Then the decoder uses those representations to generate the output, which would be the translation in another language.
Okay. Encoder processes, decoder generates. Got it. But the paper mentions these things called stacked layers and multi-head attention, which honestly sounds kind of intimidating.
Yeah.
What are those all about?
It might sound complex, but the idea is actually pretty intuitive. Think of these stacked layers as a series of filters, each one kind of refining the information from the previous layers. It's like taking a blurry photo and applying multiple sharpening filters to bring out the details.
Okay, so each layer like makes the model's understanding of the sentence more and more precise.
Exactly.
But what about this this multi-head attention? It's like the model has like multiple personalities or something.
That's a fun way to think about it. Imagine you're reading a sentence, right? You focus on different aspects of it, depending on what you're looking for.
Right.
Multi-head attention allows the model to do the same thing.
Okay.
It's like having multiple experts, each focusing on a different aspect of the sentence, and then combining their insights for a richer understanding.
So one head might be looking for grammatical relationships,
Right.
while another focuses on like the emotional tone or something.
Exactly.
That's pretty cool. But how does the model keep track of the order of the words? If it's looking at them all at once, wouldn't that like get jumbled up?
That's where positional encodings come in. It's a clever way of giving the model information about the position of each word in a sentence, so it doesn't lose track of the sequence.
Okay, that makes sense. So we've got the encoder with its layers and the multi-head attention. Then the decoder doing the same thing on the other side. What else is going on in this architecture?
Each layer also includes these things called feed-forward networks, which are like mini neural networks. Within each layer, they further process the information.
Yeah, okay.
adding another level of sophistication to the model's understanding.
It's amazing how much complexity they packed into this model.
I know, right?
And to think that all this came from that initial idea of self-attention.
It really is remarkable, and the impact of the transformer extends far beyond just the tasks that were mentioned in this paper, right?
Right.
Remember, this paper focused on translation and parsing, but the authors hinted at the possibility of applying this model to all sorts of other data.
Right. You mentioned images and audio and video earlier. Are we actually seeing that happen now?
Absolutely. The transformer's flexibility, it makes it adaptable to all sorts of tasks. We're seeing researchers use it for image recognition, where it analyzes the relationships between pixels instead of words.
Wow.
There's even work being done using transformers for music generation. Understanding the relationships between notes and melodies.
So it's like this one model has unlocked like a whole new way of approaching machine learning.
Yeah, and there's another intriguing idea the authors brought up.
Yeah.
This idea of making generation less sequential. Current models like GPT-3,
Right.
while impressive, they still create text word by word.
Right.
And this can be limiting, especially when we think about really creative tasks.
So instead of generating things step by step, they envisioned models that could create like entire chunks of text,
Yeah.
or music, or even images all at once.
Exactly. Imagine a model composing a symphony, right?
Yeah.
Not note by note,
Yeah.
but by conceiving whole musical phrases simultaneously. That's the kind of leap forward they were hinting at. And while this is still very much an active area of research,
Yeah.
we're already seeing promising progress in that direction.
That's incredible to think about. So to bring it all back to our listener, like what's the big takeaway from all this? Why should they care about this paper and the transformer?
The key takeaway is that we're living through a fundamental shift in how machines learn. This idea of attention, this ability to analyze relationships between data points is proving to be insanely powerful.
Yeah.
It's changing how we approach natural language processing, image recognition, and even creative tasks like music generation.
This one paper, Attention is All You Need, it really has like opened our eyes to the potential of machines to understand the world in a way that's much closer to how we understand it.
And that's a powerful thought.
It is.
As we continue exploring this concept of attention, who knows what other tasks machines will be able to master.
Right.
The future of AI is wide open.
Yeah.
And this paper was a huge step towards that future.
It's truly mind-blowing. We started this deep dive wanting to understand this one paper, and we ended up discussing the very nature of language and the future of AI.
I know, it's amazing.
Thanks for joining us on this journey, and stay tuned for our next deep dive.